So if you remember last year, we came also at Société Générale to the DockerCon, and we were featured as a talk because we had set very high ambition for transformation to the cloud, and we have been choosing Docker. So I won't talk about the genesis today about how we came to Docker, but I will talk about what we have done in 1 year and how we apply this ambition. So, okay, click. No, my hand. So 80% of application into the cloud, it's just mind-blowing. We have more than 1,000 applications. We have many thousand developers here. So with the model of Docker, we had to make some adaptations to make it usable by everyone with all the skills they have. And so we have built it on 3 foundations that we'll talk about. So the first foundation is a foundation of strategy for us, is to talk about the no-ops advantage. When you say no-ops, it means that everything is automated and you know what you're doing. Actually, when you're a developer in such a complex environment with banking regulation and security and so on, you cannot know all about this. And even so it will be all automated, it's not enough. So our point of view for us is to have one single cluster of Docker, which is managed by the ops and the security team for us, so that the developer are left only with the easy part. That's precisely what we do. The second part of the foundation, after getting out of the way, is to adapt to our organization. With an operating model, that means that on your desktop you can do everything you need to do, but when you have to push it to the live environment, be it on development or in production, you go through an automated process. So it starts with a Jenkins master, which is dedicated to your application, popped in a Docker container, and it spawns the agents that will do the compilation, the build image, the security checks, the Docker deploys, the integration test, and the monitor. All of this will be secured by the ops teams and the security team. So the only way to push an image into the D tier to be usable in production or in development will be to go through this process. So it means that you have the freedom to build everything you want, but when it goes live, we know what's running on. And the last part, it's about making things simple, powerful. Things simple, as we just saw. And for us, the big challenge is to have multiple environments. From the exposed zone to the public cloud, it takes 300 steps to put an application over there. It's much more difficult than the rest of the deployment. And it will require a full ops and full DevOps and full security people for each of our 1,000 teams, which is not possible. So we rely on the topology templates that we will co-book for our developer and the relevant security workflow to enable our developers to have a uniform experience to develop and deploy their application on any environment that is needed. So all of this is strategy and its capacity, but when it comes to moving the real application with a tight agenda, we have discovered many things, and especially on the configuration part. So I will invite Lee and Gilles to talk about our main application that is going to production.
Thank you. All right. Thank you very much for attending. I am Gilles Philippard. I'm a software engineer at Société Générale.
And I'm Lee Namba. I'm a solution architect for Docker, and I'm based out of Paris, France. Okay, so today we're going to be talking about the exciting topic of configuration management. How many people here today have to deal with configuration management? All right, now how many people love configuration management? All right, well, with Docker, you're going to see it's a little different. We're going to go over some major topics today, basically what components should go into an image, and then how do you configure those images once you've constructed them, and then all of that configuration that you've done, how do you put that into version control. These topics are also addressed in a reference architecture that you can find on our website at the URL there. It's called Development Pipeline Best Practices Using Docker Enterprise Edition. Okay. Now, what we're going to do is, with these topics, I'm going to introduce the first part, which will be a little bit more generic, and then we'll see actually how Société Générale and the financing platform have implemented those topics. Okay, so what I do is I go into enterprises and I help companies Dockerize their applications. And on the first day, we usually go in, and we can Dockerize an existing microservice, get it up and running quite fast, and the developers are usually pretty happy, just like this baby. But as we'll see, it's not quite that easy, and the journey is a little bit long. And so what we're going to do is take a look at how from that first Docker file goes to when you have to deploy it as a full stack across many environments, development, integration, UAT, pre-prod, prod, etc. And we're going to take you through that journey.
Yeah, so don't laugh. This was our first Docker file. And this is what we came up with after 20 minutes of work building our first image. And honestly, most of the time was spent building that Java 8 base image. But now we're in production, and I can tell you that this is quite different. So now, before diving into our architecture, let me tell you a bit more about our business. So we've built this financing platform to power the business of the global finance division at Société Générale. And they provide solutions to companies to raise capital, finance their project, and hedge against risk for their key transactions. We do business in a lot of sectors. For example, did you know that we helped fund the Miami Stadium renovation back in 2007 for the Super Bowl? And we also help finance infrastructure projects like bridges and universities. We also advise services to providers, traders, and end users of natural resources such as energy or metal. Well, let's see now how we architect that platform. So, it's built around a microservice architecture because, you know, it's cool. And not only cool, but it's also provide a lot of benefits. These microservices, they are business-oriented. So it's called DDD for those familiar with the term, domain-driven design. And since they have a completely separate lifecycle, it means you can update any of these guys when you need to. So it provides a lot of agility. And another benefit is you can write them in any language you want, as long as they speak the language of the system. And this language is REST and RabbitMQ messages. We already use Kotlin and Java, and let's hope we can put one in Clojure as well in the near future. And all these services, they are stateless Spring Boot applications. And we don't have just those displayed here, but in fact, we have more than 30 of these. So we want migration to be nice and smooth. So we don't want to refactor the application just to migrate to Docker. So we chose a lift and shift approach. And this means we don't want to change anything in the code or anything in the configuration. And any refactoring will have to come later because we want to do canary deployments. So if you don't know what it is, it's going to have, we are going to have Docker and VM versions of the same service run side by side in production. And we will flight some traffic progressively from the VM versions to the Docker instances. But we have another challenge. We have so many environments to deal with. So we have dev, integration, homologation, UAT, production, and sometimes dedicated environments that live only a few weeks. So we also have to find a way to keep track of what goes into these environments.
Okay, so one of the first questions that gets asked is what should go in an image? So you can have lots of components in there. You can map things as a volume. Should you inject things as environment variables? There's all sorts of different options. Should you bake everything in? What should you do? These are some of the very first questions that are usually asked. And the answer is classic consultant's answer, right? Well, it depends. There's usually, in the beginning, two major types of images that we like to separate. The first type, these are images that are dedicated to build the applications. So these are more of a tool type of image. They're going to run once on a single instance. So you could throw all sorts of tools in there, like a JDK or any type of library, scripts, all sorts of things that you need. You don't necessarily need to optimize that. And then the second type is the ones you actually want to run. And these, you want to slim them down, and you want to usually stick to the best practice of one component per image. So that might be an app server, that might be a database engine. And as we saw earlier in Solomon's keynote today, now we have multi-stage builds. So you can now combine all of these into a single Docker file. Now we're going to dig a little bit deeper into run type images, okay? So now in run type images, we have there are three major types. The first one we're calling base image, all right? So in general, what you do is you want to have all of your middleware in the image, baked in, and then what you can do is you can mount a volume, and that's where you can put your application and its configuration. So let's say a jar or WAR file, in their cases, a jar file, it's microservices. And the advantage of this is it's very flexible. It's good for development. You can, it's on your file system, so you can just change the files very easily. And then on the other side is what we call environment images. And this is where you bake everything into the image. You bake in the version, you bake in all of the configuration. And the advantage of this is it's very portable. In other words, you can move it from one environment to another, and it will always be exactly the same. The other advantage is it's very traceable because everything's in the image. So you don't have to move your volumes along with the image. And then you have something in the middle, which is what we call a release image, which is a compromise between the two. And what we do here is you keep why we call it release images, it's usually with the release of an application that goes into the image, and then you inject in the configuration per environment that you target. And we call this environment agnostic. So why don't we see which one the financing platform chose?
Yeah. So in our first try, we tried to put everything in a single image. So base Linux distribution, Maven, JDK, and OGS, you name it. And that kind of Dockerfile is difficult to maintain because if you're familiar with Bob Martin's SOLID acronym, the first S stands for Single Responsibility Principle. And this is a clear violation of this principle because this Dockerfile does too much. And besides, it's not reusable. So we also tried to put the environment configuration inside the image. And this is a bad idea because now your image is tied to a particular environment, as Lee said. So in the next iteration, we pulled out the environment configuration. And now it's better as it's environment agnostic, but you still don't get much reuse across teams. So finally, we settled on this organization. So GTS on the left side is our ops team. So they focus on low-level details like hardware, operating system, security patches, and network settings. And here in the middle, in the dashed rectangle, the images are used at build time only. And their purpose is to build the application packages like jar files or uber-jar for a Spring Boot application and Minify.js applications. And it's under the responsibility of the transversal architecture team. And they also provide a minimal Java runtime environment base image, which is very lean. So my team on the right is responsible for building the release images, the ones that go into production.
Okay, so now we saw how they distributed and what components went into each image. But now we need to actually configure those images, and there are many different ways of doing that, okay? So he's getting a little older there, and he's confused. So let's take a look at this. So let's take a simple example. Let's set a simple variable, right? Simple enough? You can, when everybody first starts out with Docker, usually do it in a Dockerfile. Awesome. Let's set a variable foo equals bar. It's baked into my image, no problem. But then when I actually want to run it, I'd like to change that. Okay, no problem. Do a Docker service create, and I can pass in that same foo bar at runtime. So you're like, okay, that's cool. But I'm getting tired of typing it in every single time. Okay, let's throw that in a Docker compose now. Great, foo equals bar. We're good. Now let's see, oops, I got about 100 of these environment variables that I need to set. So got something for that too. We'll throw it in an environment file. But a couple of these things we actually need to read in from an external source. So where should I put that? I can actually throw that in a script file, in an entry point. So I'll curl out to an external service. I'll set my variable at deploy time. That works. But now maybe one of those environment variables is a secret. It might be a password. So at that point, I'm going to be keeping it in as a secret now. So how do you decide? Basically, and there's even more ways, but how do you decide which way and which file a simple environment variable should go into? So one way of thinking about it is, think about the life cycle. So is this variable, is it long-lived? Is it short-lived? When are you going to use it? And so what we're going to do now is look a little bit at what we call life cycle buckets. Now if they're more long-lived, what you can do is you can throw them in the image. And what are these long-lived type of variables? These are things that might be enterprise policies or tools, credentials. These are things that can go all into an image because they're not going to change that often. And then you want to be able to share them with other teams via a base image. And then there are other types which want to change every single time you deploy something or per environment, or even once it's deployed and you want to read it in at runtime. So try to think about these things in terms of life cycles and buckets. All right? So now we're going to take you through and see what they did with the financing platform.
Yeah, so let me show you some of these Docker files we created. So this is the base image from the ops team. And they get to decide which Linux distribution should be used. Here it's Red Hat Enterprise Linux. And how they configure the YUM repositories and also the certificate authorities which should be trusted. We don't expect this image to change very much over the course of a year. Next, the Java runtime environment image. So it's maintained by the architecture team, and they choose which Java 8 update is safe to use in production. They know better because they run security tests, they check compatibility with the underlying OS, and they also check the bugs which have been fixed in the latest releases. They also install a stronger encryption policy than the one which is bundled with the JDK by default. And this one is our microservice-based image, and we are responsible for it. So we choose which user gets used to run the application and which group they belong to, and also which ports gets to be exposed. Please note the entrypoint shell script here, because I will get back to it in a few minutes. And finally, these are the release images, and they don't get anything in particular because all these microservices, they are just lookalike for now. So these images are built by our CI/CD pipeline whenever the microservice source code changes. And now this is an excerpt of our Docker compose file, now Docker stack. And you can see how we specify the name of the environment that we want to run this service. Some log/node configuration, and a credentials file which will be sourced later on because it has been declared as a Docker secret. So back to that entry point. First, we source the credentials file we saw earlier, and then we can use those secrets for the rest of the script. And we currently use a deployment tool which also acts as a CMDB. So CMDB stands for Configuration Management Database. And this is quite widespread in enterprises. And this tool, it requires configuration data to be in a certain shape, and the application then must use certain placeholder format so it can match and dereference those placeholders when it deploys the services onto virtual machines. So today we have this big Git repository which all the configuration data, and it's in Yera format because obviously we used Puppet before. And today we still upload that configuration data into the CMDB, the deployment tool. Now, in the Docker world, we don't need that deployment tool anymore. So to avoid duplicating that configuration to be Docker friendly, we decided that the entry point was the perfect time and place to kind of monkey patch the configuration. So we convert at startup time the Yera configuration file into multiple properties file, which then can be either consumed directly by our Spring Boot applications or be sourced as environment files.
That sounds like a lot of work.
Yeah, it is.
So now you should look like this. We're not little babies anymore, but we're wise, right? So after you've divided up into all of these different places where you can put your configuration, you still need to now store it somewhere. So where do we put it? And as we're talking about earlier, we're most likely going to put it into some type of version control. But even then, how do we organize that? Well, in the Docker world, it's just like coding, right? As Jill said earlier, it's not, we're not throwing it in any type of CMDB. So this is basically how they were before. So it's more configuration based on data. And what does that mean? It usually means a different tool, a pretty heavy tool. And it's not a tool that's used by developers. And in the Docker world, we're going more towards configuration as code. And what does this mean? It means it's just text files. And that also means that you can store it in version control. It can sit next to code, source code. And one of the nice things about that is it's the same tool that developers use. So that's just helping the whole dev and ops world to speak the same language instead of having that wall or that barrier. But even if you throw things in version control, you should still think about life cycles. What do I mean about that? Basically, you should probably put all of your files used to build images in a separate repository because they live the same life cycle. So once you build a new version of source code, you're going to maybe update your Docker files and all of your environment files that go with it. It usually stays in the same release pattern and life cycle. And then you should probably create a second repository for everything that involves runtime. Because it's on a different life cycle. You might want to take a certain release and deploy it to a certain environment, take an older release and deploy it to a different environment, take the next release, deploy it to another environment. And one extra pro tip on that is instead of throwing all of these runtime configurations into a single master branch where you go across all environments, one thing you can do is throw each environment into its own branch. Like we show right here. And the advantages of that is for each environment, you can have a really nice just history of what was deployed on this environment. And you can tag things a lot easier, and it avoids just having just one big mess of configuration files across all different environments. So let's take a look now how the financing platform kind of went along this journey from configuration as data to configuration as code.
Okay, so as I hinted earlier, we tried to bake environment configuration into the image. And So we cloned the configuration repo I talked about into the build directory before building the image, and you just use a copy directive, right? So as a benefit, you get full traceability for free because now everything is in the image. But you just have to make sure to keep track of which image tag has been deployed into each environment, and especially in production. But there are a few downsides. You must copy all configuration to be environment agnostic, obviously. And you must rebuild all images when the configuration changes. And so it's not build binary only once, which is quite a fundamental idea in continuous delivery. Now we think the best way to cope with environment configuration is through the entry point. So using this technique, images are environment agnostic, and you don't need to rebuild images when the configuration changes. So you just restart the container, and there you go, your new configuration is here. Because now the clone is inside the entry point. As a downside, now you need Git in the container. So it might be a security issue for some of you. But, and you also lose out-of-the-box traceability because unless you use a log which store the configuration commit that was used when deploying the containers, you might object that the container holds the Git repo, but you don't keep stub containers forever. So you might lose that information. Now, what's coming next? We think it doesn't make sense to have a big monolithic configuration repository when you are doing microservices. Because we want these microservices to be completely independent one of another. So we are going to have a dedicated run repo per microservice, like this. It will have its own Docker compose file or Docker stack file. And the environment configuration will be in branches, as Lee said, because we've tried master branch, and it's a bit difficult to refactor because once you begin to move stuff for the development environment, it's difficult not to impact the production one, especially if you have common files in between. And we'll do it for each microservice as soon as it runs only in Docker and not from the VM anymore. And one particular interesting target for us is also the blue-green deployment, so we can reduce downtime and also have an immediate rollback.
Okay, as you can see, when we started, we had just a very simple Docker file, and we took them through a journey of actually getting into production. This system went live last week.
Yeah.
And it's still running?
Yeah, it is.
And so we'll go over again just the three different topics we covered. So they chose to use a release image, a nice compromise of throwing things baked into the image and then keeping the configuration to the environment. They also went through and they analyzed the configuration, put them in different buckets. Does it go into a base image, a sub-base image, into our different application images? Do I put it in environment files, Docker files, etc.? And then finally, they had to go through a couple iterations of going from configuration as data to more of a configuration as code and figure out how to organize that. And we hope that some of these lessons will save you guys some time and save you some wrinkles, and you'll be as happy as this baby up there.
Thank you very much.
Thank you. We'll take questions now.
If you have questions, raise your hand and wait for the mic. Thank you.
So it seems that you're using Git in a way that a lot of people might consider using a service registry like Console. So I'm curious if you considered any of the service registry options, and what is it that drove you to Git, or if you see a service registry as perhaps a future step.
Yeah. In fact, we are waiting for Ops team to build the console option so we can maybe move from asking directly from a GitHub repo, we use GitHub Enterprise, from a Git repository to switching to a console instance. But I think that we'll still have to put that configuration to feed console from somewhere. And we want to keep track of which version was deployed into that console instance for which environment, and we want the traceability that I think console won't provide out of the box. And I think...
So you wouldn't see console as being the source of truth for that? You still think that there needs to be some other...
It won't be the source of truth. I think the source of truth should always be Git, because you can handle branches, you can handle pull requests and asking for changes, etc., and merge stuff. And it's difficult to do that in console. Otherwise, you have to script everything, etc. So, but console can be a runtime source of truth if you want.
Thank you.
It's I'll just follow up on that. It's actually a debate that we have a lot of times within our customers. Is a lot of times Git as well is seen as more of a development tool. So it's not necessarily the SLAs on Git are not 24/7. So if your Git goes down, then your production goes down. So that's what we're seeing. But console is something that's more ops are see a lot more, so they can scale it and it can be 24/7. But as we're looking at the disadvantages of doing it with console is you don't get all the traceability, you can't roll back things that easily, and then you also, as he said, we're going to have two sources of truth, and it's when we're going towards the whole world of DevOps, it's nice to have just one tooling and not have to support two different tools.
Okay, so one other question that you made me think of is the three types of images where you've got a base image, a release image, and an environment image. Have you considered, in essence, caching what you know is the current config in a type of environment image, but having that environment image attempt to get a more current config when it starts up?
Yeah.
So in other words, you can avoid potentially Git downtime with...
Yeah.
Yeah. You can always override any of these. These are just sort of main ways in which you have different types of images. On all of these images, you can override. In other words, what I've seen as well is you can take an environment image that's hardened and portable with everything baked in, and then hand that to a developer. They just map a volume right over it, for example, and then they pulled the exact image from production. They run it on their laptop, map a volume to it. They push in their own configuration, right? And so there's always the override options as well.
Thank you.
Howdy. Hello. I'll just talk loud. I noticed that your Java image had a Hey, there we are. Okay. I noticed that your Java image had a version in its from line, whereas like the next two that you showed did not. So what drives your decision about whether to pin the version or not?
For clarity, I removed the versions.
Oh.
Yeah, because it didn't add...
Oh, well, then would you...
But obviously you should use versions. In fact,
Okay, so you think always pin the version?
Yeah, I skipped the version, but
okay.
they really do have a version now. Yeah, we used to use the latest, and this is a really bad idea. Yeah, granted.
Yeah, always pin.
Hi. So you started your talk with lift and shift approach. So you mentioned that you didn't want to change code or configuration for existing application, and you're talking about on a legacy application. So I'm not sure how legacy is legacy for you. But so my question is, have you had to deal with configurations that leaves outside of files, so somewhere in a database, or has to be done through an API call? And how did you solve that?
No, I didn't. But maybe you saw in Lee's slide about the curl that he did in entrypoint. Yeah. I think you could do that. You could do that.
Well, it's the other way around. So basically, if an application that needs to be put in a container has to be configured through an API.
Yeah.
and you want to pre-configure it as much as possible as part of the image. But so basically, it's a challenge. Do you put an application into the container that is fully unconfigured, and then you configure on startup, or you pre-configure as part of the entry point, or somewhere in between, or I don't know?
Yeah, there's other options. I've had a case where you even have applications where you have to install it by clicking. That's the only way to do it. And in those extreme cases, what you can do is you can actually just fire up a container, install everything, do your whole clickathon, and then just save out the image. And sometimes that's the only way to do it. So that's at one extreme, right? There's no even Dockerfile for that. And then, as you said, you can also pull back from that a little bit, and you can, in your Dockerfile, do calls and then do adds, or you can even do runs which call out, do curls into different external sources when you're actually building the image. Does that make sense, or does that answer your question?
Kind of, yeah.
Okay, I'm sorry, maybe...
No, that's fine.
We can talk after if you want.
Okay.
Hi, I was interested about your configuration file branches, and you mentioned sort of some common configuration that you might have between environments. Yeah. Did you ever run into any trouble with that common configuration that you might actually want to test in environments and pass through a pipeline? Yeah. But because you've got it on different branches, then it's difficult to sort of compare that configuration between environments.
Honestly, we haven't thought very much about it yet, about this whole environment per branch stuff. Okay. Because we do master branch, and yes, it's difficult to compare, yeah, absolutely. So we'll probably have to find a way to maybe, I don't know, check out the repo, list all the branches, and do a diff between to see what changed in between. Okay. I don't know.
Just to follow up on that, one nice thing of version control is, especially with Git, is you can just do merges and cherry picking a lot easier. And so what usually ends up happening is I went through a project where we threw everything in a master branch, and after a while, we had 10 environments, and after a while,
it's a mess.
It's a mess. You just can't keep up. If you just want to go, I want this version deployed on this environment and tag that, it's really hard to get back to that. If you put each environment in a branch, then what you're able to do is, if the branches change and they vary, certain environments on a different version, and you introduce a new common, let's say, variable across all the branches, then you can choose in which environment which ones to cherry pick and which ones to merge. And with Git, it just makes it really easy. It's all text, right? So it's way better than having it all in a master branch, and then you're like, okay, in this environment, I have to copy, paste across all of the environments. Let the tool do it for you.
Okay, thanks.
Possibly, we maybe last one or two questions. I know that the Société Générale team is here, so after we finish the section, the team will be here to discuss questions. They make sure that I remind you that. And also, just to remind that you can use the Docker Cons app to rate the sections.
Yes, vote, please.
Hey guys, nice job on the presentation. This is sort of related to the last question. But have you considered having your configuration in the same branch as the project, in the sense that you have a single Git tag that indicates this is exactly 103 of the project, and is that too pedantic to kind of go down that route? But
yeah, I'm thinking about it because it makes sense. But now you will have two reasons for the commits to happen. Once, if you want to do that per environment, and other ones for the projects and the features. So
no, I mean literally the same. Like, so in the sense that kind of what I mean by pedantic is you can get yourself into a situation where literally changing a config value is a new version of the product now, right? And meaning, so I'm kind of grappling a little bit with that myself in terms of how far do you go in the sense of, if I change the config, because configuration is code, have I effectively released again? And meaning, do I need another version?
Yeah. So in my opinion, it promotes the idea of pulling that out into another repo, because I don't see it working effectively, or you have to keep track somewhere else of that configuration, so it's back to step one. So and no silver bullet here, I guess.
Thank you.
That's a really good question.
Yeah.
It all depends on what you consider a release as well, right? And that's the eternal question is, I've changed one tiny thing, is that a new image?
Yeah, if it's static,
release, right?
it should be part of the release. You remember the buckets. And if it's environment, for example, switching RabbitMQ instance, maybe it should not be in the configuration repo. Yeah.
Oh, last question.
Have you considered, I noticed you use your secrets using Docker. Have you used external secret stores, or how would that fit into this?
Yeah, good questions. We are considering using Vault, but it was not ready to our schedule last week, so we went with Docker secrets. But yeah, we might switch at some point to Vault. Yes.
One advantage of using Vault is there might be secrets that you don't want to use within Docker, that external systems use as well. One combination that actually is working right now is to use Docker to have a master secret, and then once you have that master token, then you can go out to an external Vault in the entry point, and then pull in all of the rest of your secrets. That's another way.
Okay, thank you, everyone. Let's give another round of applause to the team.
Thank you.